show you how the semantic search work. So before I go into the demo, let me first talk about the classic search and the semantic search, right? So classic search is based essentially, it's like a keyword based search, right? While the semantic search is based on the relationship of the word and the context of the word, right? So in this demo, I will use the Python, okay, and I will use the some pre-trained model, embedding model for this demo, right? So essentially, first we have to download this, install this sentence transformer model, right? So that is the first step. Second step is actually we have to import these dependencies, right? And then I have created these two methods. First method is to convert text into the embedding, right? So in this method, I'm using this open source pre-trained model, right? So I'm loading the model, and then this model, with this model, I'm converting text into the embedding, right? Second function is for the vector similarity, where I'm passing the vector 1, vector 2, and I'm using the numpy dot product to compare these vectors, right? and and in this I have the four examples here, right? And the here actually I'm creating first the embedding for all these examples, right? So as you can see, the the first example where apple is fruit is uh, identical or close to the mango is fruit is the third example, right? And then second example, like apple, iphone is expensive, is identical or close to the fourth example, right? There is a new phone, new apple iphone, right? So we will do the comparison on this, right? So this is how we are doing the comparison, right? So I'm comparing the embedding one with the third and fourth, right? So in this case, because uh, the third one, one and third is identical, so I should be getting the semantic score close to 1, or because these are the identical texts, right? And then 1 and 4th, so 1 and 4th, so this is in context of fruit and this is in context of iphone, so I should be getting the less, right? Less than 1. So let's go and see the result here. So if you see, this is the result for first two comparison, right? So since both one and third, it is in context of fruit, so it is getting the score close to one, and then for second one, it is not similar, so it is getting the less, right? And then actually then the second part, I'm comparing the second example with the third and fourth, right? So in this case, the 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 second example is apple iphone is expensive, right? Which is not close to mango is fruit, right? But it is close to the fourth example. There is a new iphone, new apple iphone, right? So let's see a result here, right? So if you see, this is not closer, so that's why the semantic score is less. And then it is closer to the fourth example, that's why you see the score is more, right? And one more thing to notice here, I'm displaying the length of this embeddings, right? And all the lengths are coming same because these embeddings are getting stored in the same dimension space, vector dimension. This is which is 384, right? Thank you for watching this video.